Today is the day we stop hoping a system has a solution and start forcing it to confess. Gaussian elimination is the organized way to turn a messy matrix into something readable. Think of elimination as building a staircase. Once the stairs exist, walking up, back-substitution, is easy. REF is a staircase rulebook. Leading ones, zeros at the bottom, and each next leading one must move right. RREF is REF with extra cleaning. Not only zeros below the leading ones, but also zeros above. REF is room is walkable. RREF is room is spotless and your mom approves. REF gets you to a solve-friendly staircase. RREF goes further and makes the answer basically stare at you. It's like the difference between clean enough and clean enough for surgery. Quick checklist. Leading ones exist, 0 rows are at the bottom, and the leading ones move right as you go down. If those 3 things happen, the matrix is behaving. If not, it's still in its rebellious teenager phase. Same staircase rules as REF, plus the leading ones are lonely in pivot columns rule. A leading one must be the only non-zero entry in its column. In RREF, leading ones do not tolerate roommates, or should we say column mates. This is the recipe. No guessing, no random moves. We always go left to right and top to bottom, like reading a book. If you jump around, the matrix will punish you with fractions at 2 a.m. Notice the first equation has no x1, x2, x4, so it starts with zeros. Zeros are not missing work. They are the matrix politely telling you what's not there. It's like a grocery list. If it's not on the list, you don't buy it. If the top of the leftmost non-zero column is 0, we swap. This is not cheating, this is strategy. It's like moving someone with an opinion to the front row so that they can express it and be a leading character. Leading ones are the boss numbers of each row. We normalize them to 1 so the elimination arithmetic stays clean. It's like setting your measuring cup to 1 unit so the recipe doesn't look weird. Elimination is make zeros on purpose. We're not solving yet, we're organizing the battlefield. It's like clearing the snow off the driveway before trying to park. Sometimes you skip columns because they're all zeros in the submatrix. That's normal. The matrix is basically saying, nothing to do here, move along. Same move, different column. Subtract a multiple so the entry becomes 0. Elimination is repetitive on purpose. It's like doing dishes. Boring, but the kitchen eventually becomes usable. We have our staircase, leading 1 step right as we go down, and zeros are below them. At this point, the matrix is readable, like a well-formatted textbook. Before this, it was more like your friend's handwriting at 3 a.m. REF is the X-ray of the system. It reveals contradictions and free variables instantly. So the hard work is row reduction. After that, classification is basically just reading. A contradiction row is the matrix screaming, "This cannot happen." So the system has no solutions, not even one. It's like getting a receipt that says you bought -3 apples. Here every variable has its own leading one, so no variable gets to freestyle. That forces exactly one solution. It's like assigned seating. Everyone has a specific chair, so nobody can wander. Free variables are like giving the system choices. Once there's at least one choice, you get a whole family of solutions. It's like ordering coffee. Once you can choose the size, there are suddenly too many possibilities. Back-substitution is the calm part. Once z is known, y becomes easy, then x becomes easy. That's why we do elimination first. It turns 3 equations at once into 1 equation at a time. It's like unlocking a phone. Once you have the password, everything else is effortless. Free variable means choose your own adventure. You choose t, and the system tells you what x and y must be to stay consistent. It's like setting one slider in a video game and watching the other stats auto-adjust. RREF is nice because it basically writes the solution for you. You just identify which variables get leading ones and which variables are free. It's like the matrix is doing customer service properly for once. This one ends with a single point solution. So after elimination, every variable gets pinned down with no freedom. It's like a detective story where every suspect has a full alibi except one, and that one is the answer. Notice the system doesn't pin down x3, so we let it be t. Then x1 and x2 become formulas that depend on t. So instead of one solution, we get a whole parade of solutions marching in a line. This is the heartbreak case. You do all the work and the matrix tells you impossible. But that's still valuable information. It's like checking your bank account before buying something. The answer might be no, but at least it's honest. Homogeneous means everything equals 0, so the all-zero vector always works. That's why these systems are never inconsistent. It's like a party where at least one guest is guaranteed, the origin. Homogeneous systems can't have exactly one nontrivial solution. Either only the origin works, or you get infinitely many. It's basically single or polyamorous, but for solutions. You can't have more leading ones than rows. So with fewer rows than variables, at least one variable escapes being pinned down. And once one variable is free, you get infinitely many solutions. It's like having fewer rules than criminals. Someone will always find a loophole. Gaussian elimination is zeros below. Gauss-Jordan is zeros below and above, so the matrix becomes perfectly polite. It's the deluxe car wash version of elimination. Now we clean above the last leading one first. It's like tidying the room starting from the far corner so you don't mess up what you already cleaned. Gauss-Jordan is basically cleaning, but with a strict order. Once the columns of leading ones are cleaned above and below, we're in RREF. At that point, solving is just reading and naming parameters. It's like the matrix is finally speaking in complete sentences. RREF is the friend who shows up with a map and a flashlight. It tells you exactly which variables are in charge and which ones are free. Then the solution set becomes a clean parametric description instead of a mystery. Different elimination paths can look different, but they all tell the same story. RREF is the official final version, like the published book. REF is like the drafts. Many versions, same plot. With Gauss-Jordan, the matrix becomes so clean that the answer is basically printed on it. It's like switching from decoding a secret message to reading a text message in plain English. Here W is free, so we name it T. Then the system forces Y and Z to be 0 and makes X follow W by 1 unit. So the solutions form a line in 4D space, which is hard to picture. So just imagine a very committed spreadsheet. Correct answer is B. It has leading ones, 0 row at the bottom, and the leading ones move right as you go down. D and E fail because the leading entry in a non-zero row must be 1, not 2. Correct answer is C. That row means 0 equals 1, which is impossible, so the system is inconsistent. In other words, the matrix found a contradiction and ended the conversation. Correct answer is C. Homogeneous systems are always consistent, and with more unknowns than equations, at least one free variable exists. So you get infinitely many solutions. Gaussian elimination is the algorithmic way to turn a system into a staircase and then solve it calmly. Gauss-Jordan goes further and makes the matrix so clean the solution is basically visible. It's like cleaning your desk. The task didn't change, but suddenly you can actually function.